In the maze of the universe, treading on starlight, you open the wormhole's door and glimpse the future. Through parallel worlds, you see other realms' tomorrows. In non-linear time, change paints new pictures. Amidst the destruction of information, the line between now and then blurs. Future fragments vanish, opening new doors, dancing with starlight. We ask our questions, seeking time's secrets on an endless journey. Today, in Introduction to Cosmology, Lecture 18, Part 2, we will explore the enigma of wormholes, solving the secrets of future changes in time. If a wormhole exists, and one briefly stays there, gaining information about the future, and then returns through the wormhole to the present, the observed future may change. There are two ways to resolve this paradox. The first method assumes non-linearity of time. Non-linearity suggests that the flow of time is not linear, and the future can influence the past. Non-linearity suggests that the flow of time is not linear, and the future can influence the past. Therefore, upon returning to the present after glimpsing the future, the seen future would have already changed. The second method involves assuming the existence of parallel universes. In this scenario, parallel universes separate from our own exist. Following this assumption, after returning to the present from seeing the future, one would have observed the future of a different universe. Therefore, the seen future is unrelated to the future of the universe we inhabit. It is still uncertain which of these two methods is more valid. However, assuming the existence of wormholes, one of these methods would need to be adopted to resolve this paradox. The first method is somewhat innovative in introducing the concept of non-linearity of time. Nevertheless, scientific evidence for the actual existence of non-linearity of time is currently lacking. The second method is relatively conservative by introducing the concept of parallel universes. However, scientific evidence for parallel universes is also lacking. Although quantum mechanics does not rule out the possibility of their existence. In conclusion, assuming the existence of wormholes, further research is needed to resolve this paradox. If wormholes exist, the paradox can be addressed through methods such as multiverse theory. The multiverse theory posits that there are multiple universes, not just the one we know. Therefore, if one could travel through a wormhole to another universe, it would be possible to see the future of that universe. In this case, the future of the present universe changes because the future of a different universe changes. So no contradiction arises. Non-linearity of time. The non-linearity of time suggests that time is not linear, and the past and future can influence each other. Thus, if one obtains information about the future through a wormhole, that information can change the current future. In this case, the future of the present changes as a result of past information affecting the present, so no contradiction arises. Information destruction. The destruction of information theory proposes that even if one obtains information about the future, they might not understand or remember it, so the future might not change. In this case, the future of the present does not change because the destruction of information prevents the future information from affecting the present. None of these theories have been scientifically proven yet. However, if wormholes exist, they offer the possibility of resolving these contradictions. Personally, I believe the multiverse theory is the most plausible because it is already supported by the research of several scientists. If wormholes exist, and it is possible to obtain information about the future through them, such contradictions may arise. To resolve these contradictions, the following hypotheses can be considered. Information multiverse. According to this hypothesis, the universe consists of infinitely many multiverses. Therefore, if one gathers information about the future and then returns to the present, any changes in the future might have occurred in a different multiverse. Nonlinearity of quantum mechanics. Quantum mechanics has nonlinear characteristics, meaning that small changes can lead to significant results. Thus, if one gathers information about the future and then returns to the present, any changes in the future might be due to the small changes that occurred when the future information was obtained, leading to significant outcomes. Time reversal. If time reversal is possible, any changes in the future after returning to the present could be because obtaining information about the future caused the flow of time to reverse. None of these hypotheses have been scientifically proven yet. However, they are presented as possible ways to resolve such contradictions. Personally, I find the information multiverse hypothesis the most plausible because the nonlinearity of quantum mechanics is still not fully understood, and time reversal may violate the laws of physics. Nonetheless, none of these hypotheses have yet been supported by scientific evidence. Therefore, how these contradictions will be resolved will need to be clarified through future research. Following the scent of a traveling wormhole, I open the door to the future and take a look. The smile of the multiverse, the dance of the quantum, a feast of time in the universe of information, paths of space-time, crossroads, holding the future of the multiverse, a dream once heard, an old mystery, whispers of time trapped in a wormhole, the multiverse of information, the dream of the quantum, the scent that moves against time, the past of the future of the past, the cycle of time, endless exploration, the joy of the multiverse, the realm of the quantum, a transcendent world, connected in silence, paths of space-time, crossroads, the unknown future, the possibilities of the multiverse, parallel stories, the song of the quantum, the moment of the wormhole, wings of light, the moment of the wormhole, wings of light. I open the door to the future and take a look.